So our main goal for today is to discuss about hypothesis testing. Okay? So you already know how to estimate population, how to estimate two population, you know how to compute that. So for today, our main goal is to discuss about hypothesis testing. Okay? So statistical hypothesis, statistical inference is concerned with either estimation or evaluation. Let me move yung screen, okay, so that I can see it. Okay. So statistical inference is concerned with either estimation or evaluation of a statement or claim about the parameter or a distribution. Okay? Evaluation of a claim about parameter or distribution is done through a statistical hypothesis. Okay? So this time we will need to evaluate, okay, your parameter, and we call it a statistical hypothesis. Okay? A statistical hypothesis is a claim or a conjecture that may be either be true or false. Okay? A statistical hypothesis is a claim or a conjecture that may either be true or false. Okay? Take note, the claim is usually expressed in terms of the value of a parameter or distribution of the population values. Two possible actions. Okay? Accept the statement or reject it. Okay? So accept the statement or reject it. So that's the two possible actions that you can occur in having a statistical hypothesis. You can accept the statement or reject the statement. Okay? Hypothesis test. Formal procedures used to determine the probability that a given hypothesis is true. Okay? The goal is to make statements regarding unknown population parameter values based on a sample data. To prove that a hypothesis is true or false with absolute certainty, we would need to absolute knowledge. That is, we would have to examine the entire population. Uses data from a sample to judge whether or not a statement about a population, okay, or the hypothesis is reasonable or not. So conducting a statistical test, so you need this, okay? Steps in hypothesis testing. Number one, okay, be familiar with this one. Number one, formulate the null and alternative hypothesis. Number two, identify the test statistic to use with a given level of significance and the distribution of the test. Now, if the level of significance is not given, use 5%, or that will be 0.05. Okay, let's continue. Okay, and the distribution of the test statistics, state the decision rule and specify the rejection region. Number 3, compute the test statistic. Number 4, make a decision whether to reject or fail to reject HO. When you say fail to reject HO, meaning you need to accept your HO. And then number 5, state the conclusion. Okay? So we will be having these steps in hypothesis testing later on. Okay? So try to remember the 5 steps. Number 1, formulate the null and alternative hypothesis. Number 2, identify the test statistics. Number 3, compute the test statistic. Number 4, make a decision. Number 5, state the conclusion. Okay? Some questions that can be addressed through statistical hypothesis testing. A scientist might want to know whether the Earth is warming up. A physician might want to know whether a new medication will lower a person's blood pressure. An educator may wish to see whether a new teaching technique is better than the traditional one. Okay? So there are 2 types of a statistical hypothesis for each situations. Okay? Number 1, we call it the null hypothesis. And then number 2, we call it alternative hypothesis. Now, what's the difference between the two? Okay? When we say null hypothesis, denoted by H sub O, it's the statement or claim or conjecture to be tested. It's generally a statement of no change. Okay? Walang pagbabago. Next, alternative hypothesis, denoted by H sub A, is the claim that is accepted in case the null hypothesis is rejected. Okay? It is the claim that is accepted in case that the null hypothesis is rejected. Again, when we say null hypothesis, it's a statement or claim or conjecture to be tested. It is generally a statement of no change at all. Okay? So some notes in formulating the hypothesis. Number one, the null hypothesis is generally a statement of no change. Thus, a statement of equality or one which involves the equality is usually considered in the null hypothesis. Okay? Equals, greater than equal, less than or equal. So we'll be using that in formulating our null hypothesis. The statistical hypothesis is about a parameter or distribution of the population values. So the example of a statistical hypothesis are mu, okay? When we say mu, you're referring to the mean of the population. And then we do have variance of the population, that is the sigma squared. And then the other one is the population proportion. Okay, next. Null and alternative hypotheses are complementary and must not overlap. Okay, the null and alternative hypotheses are complementary and must not overlap. The rejection of null hypothesis, which is denoted by H sub O, leads to the acceptance of the alternative hypothesis, which may be directional or non-directional. Okay? Ano yung difference ng directional and non-directional? When we say directional, alternative hypothesis is an assertion that one measure is greater than another measure. It involves one quantifiers such as greater than, less than. So if your HA, okay, if your formulated HA is greater than or less than, that particular rejection, okay, we call it directional. Okay, the rejection of null hypothesis that leads to acceptance of alternative hypothesis. Okay, it depends on directional and non-directional. I will explain it further as we go along. Non-directional alternative hypothesis is a statement which asserts that one value is different from the other, and it involves the qualifier greater than equal. Quantifier greater than or equal. Not equal. I repeat, non-directional alternative hypothesis is a statement which asserts that one value is different from the other, and it involves that the quantifier is not equal. In directional, alternative hypothesis is an assertion that one measure is greater than the other, and then the quantifiers are greater than or less than. Okay? So what's the connection? So later on. Formulate the appropriate null and alternative hypothesis for the given problem. Determine the type of alternative hypothesis formulated. Number one, a medical research is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? The researcher knows that the mean pulse rate for the population under the study is 82 beats per minute. Okay, 82 beats per minute. Now, okay, what will be your null hypothesis and your alternative hypothesis in that particular manner? What will be your null and your alternative hypothesis? Okay, so your answer will be, your null hypothesis is that no change, the statement has no change, that the mean pulse rate of the patient who take the medication is 82 beats per minute. It's denoted by mu equals 82. Okay, so your null hypothesis will be the mean pulse rate of the patient who take the medication is 82 beats per minute. So you can rewrite that in symbol, which is mu equals 82. Now, what would be your alternative hypothesis? When we say alternative hypothesis, the researcher predicts what will happen. Okay, what will happen? So what will be your HA? Anyone? Going back to the problem. In this particular problem, anyone can give me the HA? HA. When we say alternative hypothesis, you're referring to the researcher's prediction. What will happen? What will happen? Ano ba yung prediction ni researcher? Anyone? Anyone? Can anyone answer my question? your HO is the mean pulse rate of the patient who take the medication is 82 beats per minute. Or we can rewrite that in symbol, which is mu equals 82. What about your HA? When we say alternative response, okay, researcher predicts what will happen. Okay? Ano ba yung prediction ng researcher? The researcher is particularly concerned with the pulse rate of the patient who take the medication. According to the researcher, will the pulse rate increase, decrease, or remain unchanged? So meaning, your HA will be the mean pulse rate of the patient who take the medication is not equal to 82. Okay? Because the prediction of the researcher, pwedeng mag-increase daw, pwedeng mag-decrease, or pwedeng as is. So meaning, that's the prediction that it will happen. Okay? Predicts will happen. Pwedeng mag-decrease sa 82, pwedeng mag-increase, or pwedeng naman as is. So that is your HA. Researcher predicts will happen. Okay? So therefore, your symbol will be mu not equal to 82. And if your HA, you're using not equal, then that is non-directional. Okay? So try to examine the symbol because we need the symbol in determining kung two-tailed test ba siya, one-tailed, or right or left-tailed. Okay? So in here, your HA, mu, is not equal to 82. So that's non-directional. Okay? Next, number 2. A chemist invents an additive to increase the life of an automobile battery. The mean lifetime of the automobile battery without the additive is 36 months. Now, what will be your HO, your null hypothesis? Okay? Meaning the statement has no change. So what is your HO based on this example? Sige nga, try to examine. So what will be your HO in this particular example? Can anyone answer my question? In this example, in this situation, what will be your HO? What will be your HO? Your HO is what?
This the mean is equal to 36.
Okay, very good. Okay, your mu is equal to 36. Okay, so the lifetime of the automobile battery with the additive is 36. So that will be mu equals 36. Now, what will be your alternative, okay, hypothesis? When we say alternative hypothesis, meaning the researcher predicts will happen. Okay, so your alternative hypothesis will be the lifetime of the automobile battery with the additive is greater than 36. That's because that's according to the problem. Chemists invents an additive to increase the life of automobile battery. So therefore, your HA, the lifetime of the automobile battery with additive is greater than 36. So that will be mu greater than 36. Now, if your HA, you're using symbol which is greater than and less than, we call it directional. Okay? If your HA, you're using symbols such as greater than and less than, we call it directional. Okay? Next, number 3. A contractor wishes to lower air conditioning bills by using a special type of insulation in houses. The average of the monthly air conditioning bills is 1,900. So in this particular example, what is your HO? What is your HO?
Mu is equal to 1,900.
Okay, mu is equal to 1,900. What about HA? What about HA? What about HA? Sige nga, try to examine. Your mu is equal to 1,900. So what is your HA?
The mu is less than 1,000.
Okay, very good. The mu is less than 1,900. Okay? But how do we say it in statement? Mu equals 1,900. So how do you say it in statement? Because in the exam, you need to write the symbol and then the statement. So how do you write it in statement? Mu equals 1,900. So that's your null hypothesis. So how do we rewrite it in statement form? How do we write it in statement form? How do you say it in statement? So to say it in statement, the average of the monthly air conditioning bill is 1,900. Okay? So that will be your null hypothesis. Now, what about your HA? You said that mu is less than 1,900. To rewrite it in statement, the average of the monthly air conditioning bills by using special type of insulation in houses is lower than 1,900, or in symbols, we can rewrite it as mu less than 1,900. So if your HA, you're using greater than or less than, we call it directional. Okay? Kapag not equal, we call it non-directional. Okay? So in here, factory that sells a particular bottled fruit juice claims that the average capacity of a bottle of their product is 250 ml. Okay, so your HO or your null hypothesis is mu equals 250, and then the other one, it's not equal to 250. So same thing with number 2. A teacher wants to know if listening to popular music affects the performance of pupils. Data was gathered from the class of 50 grade 1 pupils. The mean score was 83 and then the standard deviation is 5. A previous study revealed that the population mean and the standard deviation are 82 and 10 respectively. So meaning your null hypothesis will be equals to 82 and then the other one is not equal to 82. Okay? Here, number 3. A farmer believes that using organic fertilizer on his plants will yield greater income. His average income from the past was 200,000 per year. So in here, what will be your HO? Ano yung given? What is your HO? Number 3. Anybody? What is your HO? Sige nga, anyone? What is your HO? Ano lang? Try to examine number 3. A farmer believes that using organic fertilizer on his plants will yield greater income. His average income from the past was 200,000 per year. So what is your HO? What is your HO? Ano yung given?
Mu is 200,000.
Yes, yes, yes.
Mu equals 200,000.
Try to examine. Ano ba sabi? His average income from the past was 200,000 per year. Was 200,000 per year. From the past was 200,000 per year. So your HO will be less than or equal to 200,000. Why is it? Why? Try to examine. Why is it we use less than or equal? Less than or equal. Why? Bakit ginamit yon? Because you're talking about what? You're talking about yung past income. His average income from the past, okay? Kasi yung 200,000, it's not present. So yung 200,000, you are referring to the past. So that would be you're using less than equality or greater than equality. Okay? So your HO will be mu less than or equal to 200,000. Then your HA, okay, a farmer believes that using organic fertilizer, the researcher will predict what will happen. The farmer predicts, okay, using organic fertilizer, his plants will yield in greater income. So mu is greater than 200,000. So that is your HA. Next, number 4. What about number 4? What about number 4? The Parents Association is concerned about the proportion of vitamin B content of the burgers sold in the school canteen. The canteen claims that the proportion is only about 18%. But some parents believe that it is lower than that. Okay? So meaning, your HO will be, since we're talking about proportion, okay? Since we're talking about proportion, okay? So your HO, we're not using mu. Instead, we will be using P. P referring to population proportion. So in here, okay, so the canteen claims that the proportion is only about 18%. Okay, but some parents believe that is lower than that. Okay, so pwedeng the proportion is greater than equal to 18 or pwede namang 18. Okay, the proportion is equal to 18. Okay, or pwede namang lower than 18. So your HO will be the P. Okay, when we say P, you're referring to population proportion is greater than equal to 18. That is your null hypothesis. And then your HA or your alternative hypothesis, that will be P less than 0.18. Okay, again, people, when we say alternative hypothesis, it's the prediction, okay, what will happen of the researcher. Okay, so it's in conducting statistical test. Okay, so these are the steps. Steps in hypothesis testing. Number 1, formulate the null and alternative hypothesis. Number 2, identify the test statistic to use with a given level of significance, and then the distribution of the test statistics. State the decision rule and specify the rejection rate zone. Number 3, compute the test statistic. Number 4, make a decision whether to reject or fail to reject HO. If you fail to reject HO, meaning you need to accept your HO. And then number 5, state the conclusion. Okay? A statistical test of hypothesis is a method or tool used to decide whether or not to reject a statistical hypothesis. Okay? We need to use one-tailed test. It's used to test a null hypothesis against the directional alternative hypothesis. And then two-tailed test is used to test the null hypothesis against the non-directional alternative hypothesis. Meaning, if your HA is non-directional, so you need to use two-tailed test. Kapag yung HA daw, non-directional, we will be using two-tailed test. Okay? Ano ba yung quantifier ng non-directional? The quantifier of non-directional is not equal. Yun ang yung symbol nun, not equal. Kapag not equal yung HA, so we will be using two-tailed test. Kapag yung HA daw ay greater than or less than, and that is directional, we will be using one-tailed test. Okay, so dalawang test lang yan, one-tailed or two-tailed. So to distinguish whether it's one-tailed or two-tailed, it depends on your HA. If your HA is directional, so gagamitin natin is one-tailed. If your HA is non-directional, that is two-tailed test. It means, how can we determine the non-directional? Okay, through the symbol. If your HA is using the symbol not equal, so that's non-directional. If your HA, you're using greater than, or less than, higher than, or lower than, so that is one-tailed. Okay, so that is directional. Four possibilities when making a decision. Okay, so take note of this one. Decision, reject HO. Then the other one, do not reject HO. Okay? HO is true. We call it error committed or type 1 error. Okay? HO is false, no error committed. Okay? And then, if HO is true, no error committed. Then, if HO is false, error committed, that is type 2 error. Now, miss, what's the difference between type 1 and type 2 error? Okay? A type 1 error is committed when a true null hypothesis is rejected. Okay? Type 2 error is committed when a false null hypothesis is not rejected. Means, what do you mean by that one? Okay, I'll give you an example. Okay? Hypothesis testing is similar to a court trial where the defendant is presumed innocent unless proven guilty. Okay? So parang court trial lang yon, yung hypothesis testing. Okay? So let's say for example, your null hypothesis, the defendant is innocent. And then your HA, the defendant is guilty. Okay? When we say type 1 error is committed when the defendant is convicted, okay, convicted when in fact he is innocent. Okay? Kapag daw yung defendant is convicted pero innocent naman, we call it type 1 error. Eh, minsan naman yung type 2 error. Yung type 2 error, when the defendant is acquitted, when in fact he is guilty. Okay? Yung type 2 error naman, ang difference sa type 1, yung defendant is acquitted, pero in fact, guilty siya. So that is type 2 error. So that's the difference between type 1 and type 2. Okay? Again, type 1 error is committed when the defendant is convicted, pero hindi naman pala siya, innocent siya. So that's type 1. Yung type 2, okay, yung defendant is acquitted, pinawalan sala, pero in fact, siya naman pala yung may kasalanan. So that is type 2 error. So that's the difference between the two. Okay? So the level of significance denoted by alpha is the maximum probability of committing type 1 error. So type 1 error equals alpha. The probability of type 2 error is denoted by beta. Okay? Alpha and beta are related in such a way that decreasing one will increase the other. Alpha and beta are related in such a way that decreasing one will increase the other. Okay? A test statistic is a numerical value computed for the sample data. So general formula, test value is equal to observed value minus the expected value over the standard error. Okay? Test value is equal to observed value minus expected value over the standard error. So we need to use that formula in solving for the test statistic. Okay? What about the critical value or CV? When we say critical value, separates the critical region from the non-critical region. Critical or rejection region is the range of values of the test value that indicates that there is a significant difference and that the null hypothesis should be rejected. Okay? Again, critical or rejection region is the range of values of the test value that indicates that there is a significant difference and then the null hypothesis should be rejected. The non-critical or non-rejection region is the range of values of the test value that indicates that the difference was probably due to chance that the null hypothesis should not be rejected. Okay? Should not be rejected. Meaning, you failed to reject the hypothesis. So, meaning you need to accept the hypothesis, the null hypothesis. In short. So, critical region for a left tail test. Yan. Ito yung critical. And then, those with shaded portion, that's the left tail test. So, meaning that's the critical region. Yung walang shaded, yung plain white, that is non-critical region. Okay? Then, we do have right tail test. Okay? So, you may shaded, that is your critical region. Yung wala, yun yung non-critical region. Okay? And then, for two-tail test, yan, dalawang sides with shaded portion, okay, left and right, and then in between, that is non-critical region. Okay? Next, decision. Okay, yung last part, decision. Rule based on the test statistic. Reject the null hypothesis, H sub O, if the computed value of the test statistic falls into the critical region. Okay? Reject the null hypothesis if the computed value of the test statistic falls into the critical region. Okay? Otherwise, fail to reject it. Take note of this one, ha? Reject the null hypothesis, H sub O, if the computed value of the test statistic falls into the critical region. Kung nandun sa critical region. Okay? Otherwise, fail to reject it. Okay? Fail to reject HO. Okay? Suppose a random sample of size n is drawn from a population with unknown mean, population mean, okay, and a population standard deviation, which is sigma. You want to test the null hypothesis H sub O that the unknown population mean mu is equal to some hypothesized population mean value, which is mu sub O. Okay? So this one. So your null hypothesis will be mu equals mu sub O. When we say mu sub O, you are referring to the hypothesized population. Okay? There are three possible alternative hypotheses. The first one is mu is not equal to mu sub O. Again, when we say mu sub O, you're referring to the hypothesized population. Okay, kapag mu is not equal, again, not equal yung HA, so that is two-tail test. Okay, kapag yung HA naman daw ay greater than or less than, we call it one-tail test. Okay, dalawa lang yan, two-tailed and one-tailed. Yung one-tail pwedeng going to the right or going to the left, but still they are under one-tail. Okay, if your HA, if your mu is greater than or less than your hypothesized population, then we will consider that one-tailed. So it depends na lang kung left or right. Kapag naman yung HA mo, mu is not equal to your hypothesized population, we will be using two-tailed test. So take note of that one. Okay? Next, z-test for one population mean. Okay? When sigma is known, the z-test is a statistical test for the population mean. It is used when your sample size is greater than equal to 30. Or when the population is normally distributed and your standard deviation is known. Okay? When the sample size is greater than equal to 30 and your standard deviation is unknown, we can estimate it by S. Your sample, we can use the sample standard deviation. Okay? Pwede yung sample standard deviation gamitin. So Z is equal to X bar pertaining to the sample mean minus the hypothesized population over the standard error. Okay, paano ba kunin yung standard error? Sigma divided by the square root of n. When we say sigma, you're referring to the standard deviation. Ngayon, kung wala naman si sigma, you can unknown sigma or unknown standard deviation of the population can be estimated using the sample standard deviation. Okay? So where X bar is the sample mean and mu sub O is the hypothesized population mean. Okay? So z-test for one population mean when sigma is known or the standard deviation of the population is known. Okay? So try to examine the table. Okay? So we need this. You need this, my dear. Hypothesis, H sub O, and then H sub A. Okay? If your null hypothesis is equal to mu equals if your null hypothesis denoted by mu equals mu sub O, and then your HA denoted by the following, okay, mu is not equal to mu sub O, then to come up with a decision, we need to use the two-tailed test. Okay, we need to use the two-tailed test. Yan. If your HA is greater than mu sub O, we need to use the one-tailed test, or that is the right-tailed test. Okay? Isang tailed lang, pero going to the right. Okay? Next, if your mu is less than the hypothesized population, then we will be using left-tailed test. Okay? If z is less than the negative z alpha, then we can reject HO. If the absolute z value is greater than z alpha over 2, then we can reject HO. If z is greater than z alpha, then we can reject HO. If not, if the condition it's not permitted, then we need to fail to reject HO. So kung yung condition hindi applicable, you need to fail to reject HO. Meaning, you need to accept your HO. Okay? Kung hindi pasok din sa mga conditions. Okay? Decision rule. We can only reject HO the following conditions. So number 1, kapag two-tailed, your absolute z value is greater than z alpha 2. Okay? Next condition, z value is greater than z alpha. Third condition, z is less than negative z alpha. Okay? So kung pasok naman sa conditions, you need to reject your HO. If not, fail to reject it. Okay? Let's continue. Okay, example number 1. Here we go. Okay, number 1 example. Automotive engineers tested that the gas mileage of a passenger car model from a certain car company, okay, a random sample of 35 cars resulted to a mean gas mileage of 15 kilometers per liters and a standard deviation of 2.5 kilometers per liters. The car company claims that the passenger car model has an average gas mileage of 16 kilometers per liters. Okay. Test if this claim is valid at 5% level of significance. 5%, that is 0.05 alpha. Okay, your alpha is 0.05. Okay, 5% level of significance, you're referring to alpha. Your alpha is equal to 0.05. Okay, that is 5% level of significance. Okay, now, first and foremost, we need to, first step, formulate the HO and HA. So we need to formulate the null hypothesis and the alternative hypothesis. Okay. So again, automotive engineers tested that the gas milling leakage, okay, in kilometers per liters of the passenger car model from a certain car company. So in here, what will be your null hypothesis? Anyone? What will be your null hypothesis? Can anyone give me the null hypothesis? What's the null hypothesis? What's the null hypothesis in this particular? Automotive engineers tested that the gas mileage in kilometers per liters of a passenger car model from a certain car company, a random sample of 35 cars resulted to a mean gas mileage of 15 km per liters and a standard deviation of 2.5 km per liters. The car company claims that the passenger car model has an average gas mileage of 16 km per liters. Test if this claim is valid at 5% level of significance. So first, you need to identify the null hypothesis. So can anyone give me the null hypothesis? Okay. Statement, claim, or conjecture, no change at all. No change. Ano ba yung no change dito? Anyone? What's the no change? What's the no change, my dear? What's the no change? Can anyone give me the answer? What's your null hypothesis based on the example that we have? So your null hypothesis is that a claim, conjecture, or a statement that has no change. So in here, ano ba sabi nung company? The company says that they claim that the passenger car model has an average of what? Ano ba yung kiniklaim nila? Meron silang average na what? They claim that the average gas is 16. So therefore, your null hypothesis will be the passenger car has an average gas mileage of 16 kilometers per liters. So to rewrite that in symbol, mu equals 16. Yun yung claim. Mu equals 16. Now, what will be your HA? Ano yung HA? Going back. Ano yung HA natin? Going back to the problem. Ano yung HA? Anybody? What's your HA? Anyone? What is your HA? Hello, can you hear me? Can you still hear me, people? Narinig ba? So what is your HA? In that particular, what's your HA? What is your HA? If your HO is mu equals to 16, what is your HA? HA is, ang HA can be directional and non-directional. So what's your HA? Anyone? What is your HA? Let's see. Can anyone answer what's your HA? Your HA is that the average gas mileage of the passenger car is significantly different from 16, meaning hindi siya 16 kilometer per liters. So your HA will be mu is not equal to 16. Okay? Mu is not equal to 16. Now, your HO, mu equals to 16, and then your HA, mu is not equal to 16. So that's the first step. Formulate the null and alternative hypothesis. Then what's next? Number 2. Number 2, you need to identify the test statistic, okay, to use. And how do you do that? With a given level of significance and the distribution of the test statistic, state that the decision rule and specify the rejection region. So in here, since the sample size is greater than equal to 30, use z-test. Two-tailed. Miss, bakit naging two-tailed? Okay, going back. Ano ba yung HA natin? Ano yung alternative? Is it directional or non-directional? So kapag yung sample size daw is greater than equal to 30, we will be using z-test. Kapag less than 30 naman, t-test. Okay? But how do we determine if it is one-tailed or two-tailed? Kapag two-tailed, meaning your alternative hypothesis is non-directional. Miss, paano malalaman yung non-directional? Okay? Non-directional meaning it's not equal. Okay? Not equal. Okay? So since your alternative hypothesis is not equal to 16, mu is not equal to 16, so that is non-directional, so we will be using two-tailed. Okay? So the decision rule with alpha 0.05, because 5% is 0.05. Reject HO, going back to the table. Okay, yung table. Yung table na pinakita ko a while ago, this one. Okay, yan, going back to the table. Okay, going back to this. Decision rule, reject HO if, okay, so two-tailed yung gagamitin. So since two-tailed, so we will be using this one. Okay, eto. So we will be using this because we're using two-tailed. Okay, so we'll be using this one. This one. Because the given is two-tailed. Okay, the given is two-tailed. So we will be using this one to come up with a decision. Kung i-reject ba yung HO or fail to reject. So ito yung gagamitin kapag two-tailed. Okay? Miss, why is it z-test? Z-test because your sample size is greater than equal to 30. Okay? Kapag greater than equal to 30 daw yung sample size, we will be using z-test. Kapag lower than 30, t-test. Eh yung sample size natin is 35, which is higher than 30. So we will be using z-test. Okay? And then what tail? Is it two-tailed or one-tailed? So we will be using two-tailed. Why is it two-tailed? Because your HA is non-directional. Paano naging non-directional? Mu is not equal to 16. Okay? Okay, so going back. Okay, so reject HO if the absolute value of Z is greater than equal to Z alpha over 2. Okay? Z alpha over 2. Z alpha over 2. Okay? So that is Z alpha over 2. Eh ano ba yung alpha na given? 0.05, diba? So that will be Z alpha 0.05 over 2. Ano ba yung 0.05? What is 0.05? 0.05 divided by 2. What is 0.05 divided by 2? 0.05 divided by 2, that is 0.025. So this will become Z 0.025. Okay, 0.025. And then using the table that you have, okay, eto, yung sinend ko sa inyo, what is 0.025? Oh, 0.025. So Z alpha over 2, or which is equivalent to 0.025. And is paano nakuha yung 0.025? Ang given natin ay 5%. Diba? Sabi 5% daw. 5%, that is the same as 0.05. So, ito yung alpha mo, 0.05. Now, to determine the z alpha over 2, 0.05 divided by 2, that is z sub 0.025. Okay? So, yung 0.05 divided by 2, it will become 0.025. Okay? 0.05 divided by 2, it will become 0.025. Now, using the table, yung z alpha, okay, ano daw yung z alpha over 2 na 0.025, that is 1.96. Okay? Z subscript of 0.025, that is 1.96. So, you need this table. Okay? So, 1.96. So, if your z value, the absolute z value is greater than 1.96, then you may reject your HO. But we don't know, so we need to compute pa. Okay? Next. Otherwise, fail to reject HO. So, rejection region. Okay? So, saying two-tailed yung given, so we need to draw a normal curve. Kapag two-tailed, yung shaded region, both sides, left and right. Okay? Yan. So we have negative 1.96 and positive 1.96. Okay? Left and right. Okay? So negative 1.96, positive 1.96, since the given is two-tailed. Okay? So yung may shaded region, that is your critical region. Okay? Critical region. Okay, next. After that, compute the test statistic. Okay, so in the exam, you need to follow the procedures. Okay, so number 3, compute the test statistics. So what will be the formula? So the formula is, note, since n is greater than equal to 30, we can use S to estimate sigma, if sigma is not given. Okay, kapag hindi daw given yung standard deviation ng population, we can use the standard deviation of the sample. Pwede daw yon. Okay? So, the formula in determining the test statistics, nandun yun sa table. Okay, the table a while ago that I gave. Ayan. Yan, okay? Z equals to sample mean minus the hypothesized population over sigma divided by square root of n. Okay? So, kung hindi given si sigma or the standard deviation of the population, you can use the standard deviation of the sample. Okay? So, going back. Medyo matrabaho nga lang. Okay? So, after number 2, after we identify the test statistics, number 3, compute. Okay, so we need to compute. Compute the test statistic. So, we have z is equal to 15 minus 16. 15 because that is your sample mean, 15. Okay? Yung 15, nanggaling siya sa 35 random cars. Okay, based on the problem that we have. So, 15 minus 16 divided by 0.5 over the square root of 35. 35 there, that is your sample size. Okay? That will be equal to negative 2.37. Now, decision. What will be your decision? So, since the absolute value of negative 2.37 is greater than 1.96, do we need to reject HO or fail to reject? Do we need to reject or fail to reject? The value is negative 2.36. So, kapag two-tailed test daw, remember kapag two-tailed, we can only reject HO if absolute Z value is greater than Z alpha over 2. So in this particular answer, the absolute value of 2.37, is it greater than 1.96? Greater than ba? Yung absolute value of negative 2.37, is it greater than 1.96? People, is it?
Yes, ma'am.
Okay, yes. So kapag yes, okay, absolute value of negative 2.37 is greater than 1.96. So meaning we need to reject HO. Okay? I-reject si HO. Kapag ni-reject si HO, what do you mean by that one? Reject HO meaning you need to accept your HA. So therefore, what is your conclusion? Ano yung conclusion natin? Anyone? Ni-reject si HO. So what will be your conclusion? Ano ba yung HA natin? So we need to accept your HA. Ano ba yung HA natin a while ago? Based on the example that we have. What is your HA? Anyone? Ano ba yung HA natin? Sabi reject daw HO eh. Kapag ni-reject si HO, we need to accept your HA. So going back, ano yung HA natin? The average gas mileage of the passenger car is significantly different from the 16 kilometers per liters. Now, so what will be your conclusion? What is your conclusion? So your conclusion will be, Therefore, there is enough sufficient evidence that the 5% or 0.05 level of significance that therefore there is enough sufficient evidence that the that the 5% or 0.05 level of significance, okay, that the average what? The average of what? The average gas mileage of the car is not equal to 16 kilometers per liters. Therefore, there is a sufficient, okay? Therefore, there is enough sufficient evidence at 5%, okay? At 5% or 0.05 level of significance that the average gas mileage of the car is not equal to 16, or in short, mu is not equal to 16. Okay? Or is significantly different from 16. So you can use not equal to 16 or significantly different from 16 kilometers per liters. So that is your conclusion. So your conclusion is always start from the word therefore. So therefore, there's no sufficient. Kapag you use there is no if you fail the HO. Kapag ni-reject yung HO, use there is. Okay? There is sufficient. Kapag reject yung HO, kapag fail to reject naman, use there is no enough. Okay, dalawa lang naman yan. Kapag reject HO, you may use there is enough evidence. Kapag ni-reject mo yung HO, use this kind of statement. Kapag naman fail to reject, use this statement. There is no enough evidence. Okay? So dalawa lang yun. Okay? Next, number 2. What about number? A medical investigation claims the average number of new patients in a week in a local hospital is 15. A random sample of 30 weeks yield a mean of 16. Patient with a standard deviation of 4.7 test this claim using alpha 5% or 0.05. So in number 2, first we need to determine the HO, the null hypothesis. So what will be your HO in number 2? Anyone, what is your HO? What is your HO? What is your HO? Anyone? So your HO will be what? So there is no enough evidence. Okay, pwede naman yan. Pwede yung ganyang umpisa. Or what? Or pwedeng statement based on the problem that we have. A medical investigation claims that the average number of new patients in a week is in a local hospital is 15. So what will be your HO based on the problem? Ano yung HO natin? Ano ba yung kini-claim? What's claiming? That the average number of new patients in a week in a local hospital is 15. Okay, so that's a statement. But how do we write it in symbol? How do we write it in symbol? How do we write it in symbol? Anybody? How do we write it in symbol? How do we write it in symbol? So this is your statement. So how do we write it in symbol? Anyone? How do we write it in symbol? Hello, can you hear me? Can you hear me? Can you hear me? Oh, what would be how do we write it in symbol? How do we write it in symbol? Mu is equal to 15. So mu is equal to 15. Now, what is your HA? So we're done with HO. What is your HA? Ano yung HA? HA will be what? Anybody? What is your HA? A medical investigation claims that the average number of new patients in a week in a local hospital is what? Is not equal to 15 or significantly different to 15. Okay? Is not equal to 15 or significantly different to 15. So how do we rewrite it in symbols? So that would be mu is not equal to 15. Okay? Mu is not equal to 15. Now next. So after we come up with our HO and HA, next is, what's next? What's the next procedure? What's the next procedure? After we formulate the HO and HA, what's the next procedure? Identify the test statistics. Identify the test statistic. Okay? With the given level of significance. So since n is greater than 30, okay? N is greater than equal to 30, so what will be using? What type of test? Is it two-tailed or one-tailed? Anong test yan? Two-tailed or one test? People, two-tailed or one test? Anong gagamitin natin? Two-tailed or one test? Based on your null and alternative hypothesis, anong gagamitin natin? Two-tailed or one-tailed? Anybody? Anybody? We will be using what? One-tailed or two-tailed?
Two-tailed.
Okay, very good. Two-tailed. Why? Bakit two-tailed, my dear? Why is it two-tailed?
Non-directional.
Okay, non-directional because we're using not equal. Diba? Not equal. So non-directional. Now, so since the sample size is greater than equal to 30, so we'll be using two-tailed. Okay, that's according to your alternative hypothesis. It's non-directional. So two-tailed. So for decision rule, okay, ano ba yung decision rule? With 5% or 0.05 alpha, okay? Alpha is 5%, or that would be 0.05, okay? So reject HO if, ano yung condition? So two-tailed test, reject HO if the absolute Z value is greater than Z alpha over 2, okay? So reject HO if the absolute value of Z is greater than Z alpha over 2, okay? So we're not yet done. Let's continue. Okay? So since it's two-tailed, remember the Z alpha over 2 is equal to what? Ano yung Z alpha over 2 mo? Since alpha is equal to 0.05, what is your Z alpha over 2? Z alpha over 2 is the same as Z 0.05 over 2. 0.05 over 2 is the same as Z 0.025. So what is Z 0.025?
1.26.
Okay, 1.96. Okay, 1.96. So we need to draw yung bell curve. Okay? So since two-tailed, kapag two-tailed, yung shaded region, both sides, left and right. So this is your negative 1.96 and then this is your positive 1.96. So nandito yung critical region nyo. Okay? Nandito na yung critical region. So that is your step number 2. Next. So after that, compute for test statistics. Okay? Compute. So since your sample size is greater than equal to 30, we will be using z-test. Okay, kapag yung sample size daw greater than equal to 30, we will be using z-test. Kapag lower than 30, t-test. Dalawa lang yun, z-test or t-test. So in here, ang given 30 weeks. So meaning that is n is greater than equal to 30. Okay? So we will be using z-test. So we have sample mean minus the hypothesized population over sigma divided by square root of n. Now, if sigma or the standard deviation of the population is not given, we can use the sample standard deviation. So in here, how do we solve for z? So z is equal to, what is the sample mean based on the problem? Ano yung sample mean?
16.
Okay, 16. So 16 minus what? 15 divided by what? Divided by what?
7.
Okay, 4.7 over the square root of 30. So what is your z value? What is your z value now? 16 minus 15 divided by 4.7 divided by square root of 30. So what's your z value? What is your z value? Anyone, what is your z value? What is your z value? Z value is what? Get a calculator, compute. Come on. What is z value? 16 minus 15 divided by 4.7 over the square root of 30. So what is your z value? Your z value is? Your z value is? Someone answer it. Okay. 3 point. Again, my dear. 16 minus 15 divided by 4.7 over square root of 30.
Miss 1.17.
Okay, 1.17. Okay, 1.17. Now, so you have 1.17 in the z value. Okay, next, decision. Okay, decision na tayo, number 4. So, number 4, decision. Okay, so going back, ano ba yung decision natin? What's our decision? Reject HO if the absolute value of z is greater than 1.96 or the greater than z alpha over 2. Okay? So since your given is 1.17, is it greater than 1.96? Your z alpha is 1.17. Is it greater than 1.96?
No, miss.
Okay. So, ibig sabihin, 1.17 is less than 1.96. So, hindi di ba? This is the condition to reject HO. But, your answer says that 1.17 is less than 1.96. So, meaning, we cannot reject HO kasi contradicting. Okay? So, if that is the case, fail to reject HO. Meaning, what is your conclusion? Okay? Fail to reject HO. Meaning, hindi mo pwedeng i-accept yung HO. Meaning, fail to reject HO. So, meaning, you need to, what? Accept HO. You need to accept HO based on your computation. Okay? Because the condition, you can only reject HO if Z alpha, if your Z value, the absolute Z value is greater than Z alpha. But after we compute, we find out that 1.17 is less than 1.96. Okay? So, contradicting. So, we cannot reject HO. Instead, fail to reject HO. Fail to reject HO. So therefore, what is your conclusion? So your conclusion is that, therefore, okay, there is no, or there is not enough, okay, there is not enough evidence at 5% or 0.05 level of significance that the average number of new patients in a week in a local hospital is 15. Okay, so therefore, your conclusion, there is not enough evidence at 5% or 0.5 level of significance that the average number of new patients in a week in a local hospital is 15. Okay? So that is your conclusion.